Chapter 16, Complex Numbers and Eulers, page 6 for MHL. Let's look quickly at the properties of cis theta. Remember the investigation we did where we figured out that if we multiply two complex numbers together, that the resulting complex number will have an angle which is the sum of the two angles of the first two complex numbers. So if we know that we're multiplying cis theta times cis phi, which is kind of like multiplying two complex numbers with a modulus of 1, we know that the result is cis theta plus phi. Which exponent law is similar? Okay, so it's kind of like adding or multiplying like two bases with two of the same base with different exponents, and when you do that, you add the exponents. It's kind of like doing that, isn't it? What if you do cis theta divided by cis phi? So that is kind of analogous in that you will subtract the angles. Okay, which exponent law is similar to that? So that is similar to if you have the same base. And you're dividing, then you get the same base and you subtract the exponents. Okay? What if you have cis of theta plus k2 pi, where k is any integer? Remember that this is like the unit circle. So theta in theta plus 2 pi or any multiple of 2 pi is basically the same as theta. So actually that's equal to cis theta. Okay, let's move on to number 1. Use the properties of cis to simplify cis theta times cis 2 theta. So remember, if you multiply two cis's together, all you're going to do is add the arguments. So in this case, we have cis 3 theta would be the simplified version. C, we have cis theta cubed. So basically that would be like cis theta times cis theta times cis theta, and that would just be equal to cis 3 thetas because I just added all the thetas together. What about 2 cis pi over 12 times cis pi over 6? So that would be equal to 2 cis, and we just add the two angles together, and it's just going to become a fraction problem. So pi over 12 plus pi over 6 is equal to pi over 12 plus 2/12 pi. So that would be 3/12 pi would be the result. And that is equal to 2 cis of, and we can simplify that because 3/12 is the same thing as pi over 4, right? Okay. What about 4 cis pi over 12 divided by 2 cis 7/12 pi? So we haven't done, so like here it was pretty easy to see that we just multiplied those together and we multiplied by 2 at the end. In this case, can you see that we could just multiply by 4 over 2, which is 2, and then we're going to do the cis operation on cis pi over 12 divided by cis 7/12 pi, which would be equal to pi over 12 minus 7/12 pi. And so the result would be 2 cis pi over 12 minus 7/12 pi would be negative 6/12 pi, which would be negative 1/2 pi. So it would be 2 cis negative pi over 2, which would be, we can simplify that, right? It would be, oh, by the way, 2 cis pi over 4, that's the same thing as a triangle that looks like that. So it would be 2 divided by square root of 2, 2 divided by square root of 2. So if we wanted to write that in a plus bi form, we could write it as square root of 2 plus square root of 2i, but I don't think that's easier than that, so we'll just leave that. So 2 cis negative pi over 2 that's kind of an easy one to write in a plus bi form because it's pointing directly down, right? If it's pointing directly down by 2, then basically that's negative 2i, right? So maybe it would be easier to write like that. What about this one? So this one has square root of 2 cis pi over 8 multiplied times itself 4 times. So if you multiply the modulus by itself 4 times, that would be square root of 2 to the 4th. That would be square root of 2 times square root of 2 times square root of 2 times square root of 2, which would be 2 times 2, which is 4. And the cis part of it, you would just be adding pi over 8 to itself 4 times, which would be basically multiplying 4 times pi over 8, which would be 4 times cis pi over 2. And cis pi over 2, that would be an angle that's pointing straight up, so 4 pointing straight up would be equal to 4i. Okay, let's move on to number 2a. Use the property cis theta plus k2 pi equals cis theta to evaluate cis 17 pi. So cis 17 pi, that's way more than 2 pi, right? So we're going to subtract 2 pi's from it until we get something that's less than 2 pi. So we can see that eventually that is going to be like pi plus 16 pi. 16 pi is a multiple of 2 pi, right? So 17 pi is, since it's pi plus 16 pi, cis 17 pi is the same thing as cis pi. And cis pi is a vector pointing to the left with a magnitude or a modulus of 1. So that is equal to negative 1. Ooh, what about cis 91/3 pi? That's kind of hard because it's a fraction. So 91/3 pi, that's about 30 pi. So 30 pi is a multiple of 2 pi. So let's subtract 30 pi from 91 pi. What are we going to get? We're going to get 90/3 pi subtracted from 91/3 pi. So that would be pi over 3. So cis 9 pi over 3. Okay, and cis pi over 3, I don't know if there's an easier way to write that. That would kind of look like this, and the magnitude of the modulus is 1, so this would be 1/2, and this would be square root of 3 over 2, and so the a plus bi form would be 1/2 plus I times square root of 3 over 2, which doesn't look nice at all, so I don't think that we need to simplify it from this point. Cis pi over 3 is fine. What about number 3? If z equals 2 cis theta, what is the modulus of z? It's 2. And what is the argument of z? It is theta. So write z conjugate in polar form. Okay, so remember, when you have conjugate of a complex number, the modulus stays the same and the cis value becomes negative. Okay, because basically you just flip the triangle down instead to make the conjugate. Or vice versa, you start down and you go up. Okay, what about negative z in polar form? So negative z in polar form. So if you have negative z, basically you are reversing both the real and the imaginary component. So the triangle goes from the first quadrant to the third quadrant, or to the opposite quadrant basically. So in that case, instead of being theta here, you're going to have this theta, which is theta plus 180 degrees, or theta plus pi, right? So basically it would be 2 cis theta plus pi. What about writing negative z conjugate in polar form? So that would be this triangle here. So you'd have the conjugate and you have the conjugate of the negative, or you take you take the conjugate and then you take the negative of that. This is an interesting question that I never thought about before. When you have negative z conjugate, you need to respect PEMDAS here. And I'm assuming that z conjugate, the conjugate takes precedence. So you need to do the conjugate first. If you do the conjugate first, I get this orange reflected triangle here. Then when I take the negative, I get this one here. So actually it doesn't matter. The negative z conjugate, both of them give you the same thing, right? Because like if I do the conjugate first, I'm going to go down here. Then I take the negative, I go up here, I end up there. If I do the negative first, then I'm going to go down here, and then I do the conjugate, and I'll end up here. Yeah, so either way I'm going to get the solution, or I'm going to get the triangle that's up here. So if this triangle is theta, this triangle is basically 180 degrees minus theta. So I would put 2 cis pi minus theta for negative z conjugate. Last one. So write in polar form, cosine theta minus I sine theta. This is interesting. So the if I have a theta value, then this is the theta value. Then the x component is here, and the y component, I'm saying it's minus I sine theta. So actually this is kind of the conjugate of cis theta. Okay. So this would actually be cis negative theta, right? This one here. This one here this is interesting. So instead of cosine and sine like that, the x component is this. So the triangle would be kind of lying on its side, and then the y component is going to be pointing down, and it's going to be the length of the short side. So it's going to be like that. So everything's kind of switched. So instead of the theta being here, the theta is actually here. Okay, so, and like the vector is going in this direction. So what would be this angle? If this is theta, then this angle here would be 90 minus theta, or pi over 2 minus theta, right? And it's going in a negative direction because it's going to go down. So this cis is actually negative pi over 2 minus theta, which is cis theta minus pi over 2. So if z equals r cis theta, then z conjugate is equal to, and remember this is z conjugate right here, z conjugate is equal to r cis negative theta